All right, let's see how we go here. An aeroplane is flying due north, but due to a storm it flies 150 kilometres on a bearing of 60 degrees from true north and then on a bearing of 320 until it reaches its original course again. Find the angles ABC and ACB. All right, well, we've got our triangle up here. Can't quite see it. There's my stylus. All right, so we've got triangle A, B, and C, so let's make these side lengths as we normally do. Little a, little b, and little c is obviously the one there that's equal to 150. Now, 60 degrees from true north, or north's going straight up there, we've labelled that, so 60 degrees, measured in a clockwise direction is there. The other angle mentioned was 320. If that's 320, the little bit left over there must be 40 degrees to add up to a full revolution, 360. What does that mean? The gap is, well, co-interior angles, I've got 60 here. That little other one must make it add up to 180, which means it's going to be 120. So 120 minus 40, we have 80 degrees for B. So angle ABC is 80 degrees. And then 180 degrees in a triangle, of course. There's 80 and 60 is 140. ACB must be 40 degrees. There are other ways you can do that apart from co-interior angles, but I'm going to go out on a limb and say you're probably all pretty good with those already. So let's get on to the next bit, which is probably where we're having a bit more trouble. So we've got triangle ABC. This side length C is 150. A we're trying to find, B we're trying to find, and then obviously the difference between C plus A and B, that will be how much extra distance they flew. When we only have one side length, then we're going to need to use our sine rule, not our cosine rule. Cosine rule is when you've got two sides and the angle in between, or all three sides. In this case we don't. We know all three angles, 80, 60 and 40, and that's going to be enough for us to figure out side length A and side length B. So let's go ahead for side length A. A divided by sine A is B over sine B, and C over sine C. We know our rule. C over sine C, that's our rule. What are the pairs I know? Well, I know 150 kilometres and 40, and I'm going to try and find A first. So I've got A divided by the sine of the opposite angle, which is 60. And that's equal to 150 divided by the sine of the opposite angle, which is 40. So to get A on its own, obviously the opposite of dividing by sine 60 is to multiply. So I've got A is going to be 150 sine 60 divided by the sine of 40. We need to find what that's approximately equal to. Calculators out, making sure you're in degrees mode. Let's see how we go. 150 by the sine of 60 divided by the sine of 40. And we've got 202.09 kilometres. I've got approximately equals 2 there. 202.09 kilometres for A. How do I go ahead and find B? Well, I can use the sine rule again, or I could use the cosine rule. It doesn't really matter which one I use. Let's check it out both ways. So I could have B divided by the sine. Angle B is 80, so B on sine 80 equals, and I'll use the ones we were originally given just in case I made a little error there. So it's 150 divided by sine 40. B is going to be 150 sine 80. So multiplying by sine 80, we'll get rid of it on the left-hand side. 150 sine 80 divided by sine 40. B is approximately equal to, and can I even sneakily use, oh look at that, I can. 150 sine 80 divided by sine 40. 229.81 is approximately the value there. 229.81 kilometres would be the other side length. Yep, that seems reasonable. So what do we go ahead now and find out the difference in distances? So the extra distance And running out of a little bit of room here, you of course would keep working down the page, but I like to keep it all there where you can see it if at all possible. So the extra distance, what's it going to be? It's going to be C plus A, so I've got 150 plus 202.09 minus the distance B, which was just 229.81. I should be writing approximately equal to, because we know we've already done some rounding off here, and we go ahead and calculate that. So 150 minus 202.09, oh sorry, that should be a plus, and then the minus. You know that the worst bit of my maths is actually just using a calculator. Now we're subtracting 229.81, and they've asked us to round it to the nearest kilometre, so when we get our answer, 122.28, so we would say it's approximately 122 kilometres. And we're done. I hope that helps. I did promise you could use the cosine rule. Let's just quickly show that if you're keen to stick around, because you may need it tomorrow. I don't know. Chances are you're going to need it in some form or another, aren't they? So if I'm trying to find b, and I know the other side, so I've got b squared equals a squared, so that's 150 squared, plus, oh sorry, that was c squared, plus a squared is 202.09, minus, and I'm going to run out of room here, let's see if we can do it, minus 2 by 150 by 202.09 cosine, the angle opposite the side I'm trying to find b is 80. Alright, so that's what b squared is going to be. Let's push buttons on our calculator. Now we've introduced a tiny bit of round off error here because that number's been rounded off to 202.09, but I think we'll be okay given that we're going to just the nearest whole number. So 150 squared plus 202.09 squared minus 2 times 150 times 202.09 times the cosine of 80. Oh, 52,812. That doesn't sound right, does it? But that's because it's been squared. I'm making those numbers up. Was that even what it was? 52,812.6 approximately. Now we need to go to the power of 0.5, which is of course square rooting, but it's just so much faster to do that. 229.81. Oh look, 229.81 kilometres. Same as we had before. So there you go. That's hopefully helped everyone. Good luck tomorrow. Cheers guys. Bye.